Do you ever look at fractions and you see the answer and you just think, huh? How did we get here? How did 2 over 10 plus 3 over 10 equal a half? Well, if you stick around, I'll show you tips and tricks in how to understand fractions so that questions like 2 over 10 plus 3 over 10 equal a half does not catch you out. Before you try to impress your friends with all the cool tips and tricks you learned in how to add fractions, we first have to make sure that you know the basics. And that is the parts of the fraction. In a fraction, we have the top number, which is the numerator, and the bottom number, which is the denominator. But where do these numbers come from? The easiest thing to remember is that the denominator is always how many different parts the shape or the whole was cut into. In this example, our rectangle was cut into 4 equal parts. That means our denominator is 4. And the numerator is usually the parts of the whole. So I can say my numerator can either be the shaded parts of the whole, and then I get 3 over 4, or I can say my numerator is the unshaded parts of the whole, and that would be 1 over 4. So you see how my denominator doesn't change, but based on what the question is asking, my numerator can change. So a numerator is all about what we are trying to find out. Okay. Back to the original question. What is 2 over 10 plus 3 over 10? Now, the answer I gave you was a half. It's the correct answer, but our answer looks different because of something called equivalent fractions. So to understand this, I'm going to use a diagram. If you notice, my circle is cut into 10 segments, which matches my denominator. Now I'm going to frame the scenario around my numerator. I'm going to color in 2 wedges green, and I'm going to color in 3 wedges purple. So I've colored in my wedges. Now, visually, I can get the answer. I have 5 shaded in segments of my circle, and my circle was divided into 10 different segments. So I have 5 over 10. But if you remember, I said the answer was a half. And there's another way to use visual guides. Can you see visually that half the circle is shaded in? So if you look here, this half is shaded in and the other half is not. And that's how I got a half. These two fractions are what we call equivalent fractions. Because they have the same value in the whole, I'm not changing anything. I shaded in 2 segments and then I shaded in 3 segments. Those segments added up to 5 of my whole shape. And that's how I got 5 over 10. And then I used what's known as equivalent fractions to get a half. And that's one of the neat tricks of fractions. Let's get back to adding fractions. I'm going to use the same circle shape, and I know that my circle is divided into 10 segments. And let's say I want to add 4 over 10 plus 6 over 10. I'm going to shade in 4 segments, and then I'm going to shade in 6, and then we'll count how many segments are shaded in to get our answer. 1, 2, 3, 4. So there's my 4 shaded in, and now I'm going to do the remaining 6. So 1, 2, 3, 4, 5, and then finally 6. Now that all the segments are shaded in, I can write my answer as how many shaded segments I have, which is 10, and my denominator is how many segments was my shape cut into, and that was also 10. So here I have a fraction 10 over 10. And that gives us 1. My whole shape is shaded in, and that's 1. So now I'm going to move on to an example without a visual cue. And I want to see if you can identify the pattern when it comes to adding fractions. So here I have 3 over 7, 2 over 7. Okay, so where do we start with this? We don't have any visual guide to help us get the answer. We can use our question to help us get the answer. If you notice, we have a shape with 7 segments, right? I'm not changing any of the segment sizes. I'm taking this shape because this shape is cut into 7 equal pieces. My answer would be the same shape with these 7 segments. So my denominator is 7. And that brings us to one of our first rules of adding fractions. To add fractions, all denominators must be the same. So that means my answer will have the same denominator as my question. Now when it comes to figuring out the numerator, you saw in the previous questions, I just counted the shaded parts. And because I don't physically have a shape, I can just count what I have in my question. So if I have 3 and 2 together, that's going to give me 5. So the numerator when we had our picture was just the shaded pieces. What we were actually doing was adding our numerators. And that brings us to our second rule. To get the numerator of our answer, we just have to add the numerators that we have in our question. You know that 3 plus 2 equals 5. So that is my numerator over there. But I have to have the same denominator. If my denominator is not the same in my question, then I won't be able to just add the numerators. Okay, let's do another example together. In this example, I have 17 over 21 plus 1 over 21. So let me check. To add the fractions, the denominators must be the same. Check. Both of them are 21. That means my denominator in my answer is also 21, because my denominator in my answer is the same as the denominator in my question. And now to get the numerator, I just have to add the numerators in my question. So what is 17 plus 1? That gives me 18. So my answer is 18 over 21. And now if we look at it without any color coding, we can see that 17 over 21 plus 1 over 21 is 18 over 21. If we get really hard questions, we don't have to stress and think, oh my gosh, I need to see visually a shape divided into 633 pieces. No, we know that because we have the same denominators in our question, our answer will have the same denominator. And to get the numerator, we just have to add 431 plus 22. That gives us 453. And that's our answer. So far all our questions had proper fraction answers. What if we have an improper fraction answer?
But don't stress, it is possible. In the next video, I'll show you how to add improper fractions and mixed numbers. So if you'd like to see those videos, please check out my playlist above, or if you'd like to explore other topics, please visit my channel.